And with human ingenuity that knows no bounds, yes, we've invented a new battery tester, and that's not it. And we've got our equipment ready to go. And in these times of health and safety, we've got our PPE here in the form of a rubber mat, which is tested to BSS something or other. Voltage, not too sure. Maximum, it's made by Uniroyal, couldn't get better than that. And it's 1970 watt. Yeah. So all we have to do is connect our jump leads up to our batteries, and we'll see what one is any good. And of course, the tester itself. I'll bring you around here. Are you ready for this? This is Mark 1 prototype, masterpiece. And yes, there's a few bits of gear there that, well, I might have had right enough anyway. And look at that. That was a Mark 1, didn't work. Well, this is the Mark 1. Maybe no, this is a Mark 2. What are we talking about? And enough for this joviality, I hear you cry. I'm here to learn something. Oh, really? You're going to learn something here? What not to do when you've got a wee bit of time in your hands, because there's no MOTs in Northern Ireland and everybody's confined to barracks. Ah well. So I thought I would have a bit of a clear out, and that there looks as if it's been on the Titanic, and that was a wee bit better, Nick. But what is this, I hear you cry? Is there a rare looking specimen? Well, this is a high voltage dropout fuse. This one here is, I think it's 15 kV rated. Normally be used on this style here, would be on a 11 kV line in the UK. And well, we'll talk a wee bit about this, show you what the crack is. Thought you might be interested. If you want to see a car repair video, turn off now. These things, you might see them on overhead lines. 3-phase overhead line, single phase as well. And you have 2 of them on a single phase line, 3 of them on a 3-phase line. And you have 1 per phase. And you see it sort of sits like that in a holder. So there's like 2 big ears on this particular style. There's 2 big ears that accept that big sort of U-shaped thing, and then that sits in there. And then inside this tube you have a fuse element. Right? We talked a wee bit about fuses in a video a while ago, and it was all car fuses and automotive fuses and pretty 12 volt stuff. You know, this is thousands of volts. So yeah, you might be interested, but I'll put them out of the way for the minute and get the old drawing out. So we'll not dwell on this too much. You have a 3-phase main line, and off it you have a spur line. So it's going away down another line to an end. So that will be a radial circuit. So these things are known as fuse isolators. So they are fused, and you can use it for isolation as well. So if you want to separate this circuit up, so you would get that in here protecting each fuse or each phase. I mean, so say that fuse there would typically be on an 11,000 volt line. So 11 kV, 11,000 volts. But that is the line voltage. So the 11,000 volts is between a phase and another phase. So that is the voltage between there and there. But if you measured the phase to earth, so the phase with respect to earth or ground, if you want to call it that, it would be 6350, something like that, 6350. We'll just stick it in the calculator, show you how you can work that out. You may be able to see this. So 1 1 0 0 0 divided by 3 square root equals 6350 volts. So similarly, your household voltage, say you had a 3-phase supply in a house or a warehouse or something, so it'd be 415 between the phases, and we'll do the same calculation again, divided by 3 square root equals 239.6, so 240 volts. So that'll be your normal, that's phase the earth, 415 is between phases. So the voltage actually across each phase is 6.3 kV, but these are rated at, just a shot, these are rated at 15 kV. But yeah, anyway, enough of that nonsense. Right, so this horrible looking one, I don't think it's really, it's too much to do with that. This one here has the nut is broken on it, but there's a couple of threads left, so I might be able to use it. So the fuse in this is actually inside it. All this metal work here is a mechanical device, and what this is called a dropout fuse. So what happens is whenever the fuse ruptures due to an overcurrent or a fault, then this will actually fall out of its carrier and hang down then. So it'll go like that, and it'll hang down, and you'll know that that fuse has ruptured. And that's how we call fuses not blown. We do not say the fuse is blue, because that can be confused with a phase colour. So the electrical bit, or the fuse element, here's one here that I found that was lying underneath those, made in Mexico, and this is new old stock here, 11th of the 1st, 1999, and it's 40 amps and type K. So the two common types would be a T and a K. So K is a fast blow, and a T would be a slow blow. So the T would hold the current for a wee bit longer, and that's the characteristic of the fuse. And there is the element itself that goes inside that tube. Yeah, these haven't changed at all, really, and they're still in use. These type of fuses now, these type of fuse isolators, they're not as common. There's not as many of them on a network nowadays because of the use of surge diverters that can take multiple lightning strikes. So we're not going to be able to see inside that. I'll tell you what, I have another one here that I could break that off, but it's just not coming off. Seriously. So it just says on top of it 40k there. But see that bit of wire rope there? That's not the fuse. The fuse is in the other ones here, which are busmen, and they're 40k as well. So let's see. Pull one of these out, and there we are. Okay, fast. Made by Bossman, who makes a lot of fuses, well-known manufacturer. And let's see. There we go. So there's our fuse element there. So that is the weak point, which will rupture due to heat. Okay, dope. So there you are, that's what it is. And it's in that, which is basically cardboard. Not much to that. That other orange one is more, that's cardboard as well. So it is. Well, it'll be a fairly, I don't think it'll be made out of a cardboard box, but yeah. So we'll put that back over that again, and I'll show you how this operates, and hopefully my battery tester will show this thing in action. But anyway, first of all, how these are operated. You operate these live from the ground, and you can actually stick them in on load as well. So you'd operate them from the ground with a set of insulated rods with a big hook on the end of it, and you stick that in there, and the hook in there, and that lifts it up, and then you put that in and that closes it up. So you have this sort of, so you hang it like that, right, that in there, and you catch onto this and you whop her up in as hard as you can. And here's a wee video of somebody doing that. Well, that gives you an idea what we're on about. So, I got this one here. Oh, this one here is not too bad. What's in that? There's a 20 amp slow in there. So it's slightly different style of element. So, if you can get that in the camera. So, there's not much to it, as you can see, and that was in that. So that actually is a good fuse, but it's only 20 amps, and for testing our batteries, which are capable of outputting 500 and 600 amps, but albeit at only 12 volts. So these are high voltage fuses. These take thousands of amps, and what we'll do is we'll load this old one in. We'll not use a good one, because I don't want anybody thinking I'm wasting good stuff. But this 1989 one, I think we're okay to sacrifice for the purposes of science and education and all that. So we'll just screw that in there. That wee washer is crucial, that it keeps it in place and doesn't stop it from falling out. And then what we'll do is this boyo here, flip it around, and then there is a spring mechanism here, and we need to bend that down and hold it in place with the old digit, wrap that around there like that, and keep that spring under tension, and get a nut on the end of that. So I'll have to get a washer or something, because that stud's broke. Right, I have that held in place. Just nip down, and this wee tail, we'll just get rid of it up the pipe. So don't want that flailing about the place. So there we go. So that's her ready to go. So with a couple of springs going on here, we'll have that wee spring in there, and then we'll have this big spring, and this goes into a carrier and a holder, but it goes in and it compresses the spring, and it clips in at the head, so that's a contact point, and these are the contact point as well. So I'm going to get that set up in our tester here. Right, well, don't need that. Don't need that. That's old hat now. That voltmeter thing, no good. So get her going at that, and get our PPE flopped over. And we're all set up, ready to go. And of course, don't be trying this at home until these are commercially available. You didn't think a crocodile clip could talk, could you? Right, so we have our current monitoring device here, because this is science here, guys. This is science in action. We have a breakthrough new battery load tester here, and here we go. 10, 9, 8, 3, 7, 2, 1. Nom. 3, 1. No good. Looks like this battery's duff. I'm going to put a bit of current through it again. So test number 1 was an instant success. That battery is condemned right away. There we go. This is fantastic stuff here, guys. I'm going to make a fortune out of this. This is brilliant. Okay, here we go, battery number 2. 10 and 8, 7, 6, 5, 4, 3, 2, 1. So I'll have a wee and a quick look at this. So it's all gone very slack. So, okay. Well, we'll pull that. Oh, pull that out. And there's the remains of the day. That's the remains of our little fuse element there. Okay. And it's melted. It can't stand the heat. That's what I've oh, there we go. Focus! You focus. No, I want the focus. Not much to see here. Yeah, just melted. So there we go. 12 volts on a 11,000 volt fuse, but you need a bucket load of current. So did the current show up on the slow-mo there? No idea, but it doesn't matter. I don't care. What a machine! What a machine, boys! Okay, commercial inquiries to Dave Stirl, YouTube at catchyourselfon.com, and anybody else wants to know more. I think health and safety. Don't think it would work. But the proof of the pudding's in the eating. Good battery, bad battery. Thanks for watching. All the best. Bye bye now. Take care.